Okay, so sorry about that unexpected interruption. I did intend to continue the video and go straight from the pseudocode to the translation of the pseudocode into C#, but that didn't happen. So what we're instead doing now is, unfortunately I've had to add another video. So that's been done, so this is the next video. So if you found this video, then that's good, you've moved on. So we got up to this point here. So I just talked about in the previous video this pseudocode and what it means. So go back and watch that video if you haven't already seen that. And now we're at the point where we translate that code into C#. So we've got the translation process starting here. And we can see that the first thing we need to do is deal with that input statement. So get the 5-digit number, and the translation to C# is here. And of course, I haven't included the try-catch. So when you try this out, if you do, then put a try-catch around that statement. Okay. Now we need to set up the flag. Okay, so remember that we're using this not found flag, which is going to be true as long as the digit 3 has not been found in our target 5-digit number. So that starts out as true. So that statement there is, that variable there is found in C# right here. So we have a variable called not found. Its type is bool, and it is assigned the value of true. Okay. And this is where we set up the loop. So the loop has two parts. It's got a header and a body. So the header is specifying the conditions under which the loop runs, and the body is the instructions that occur inside the loop. And so the translation of the header is found here in C#, and the translation of the body is found here. So let's look at the header first. So what we've got here is a fairly complicated expression. It's got two parts, and they're joined by a logical AND. So we've talked about logical AND previously, so go back and have a look at those lectures if you're not sure what that means. Basically, the idea with the AND is it's going to combine two expressions. So the first expression is just not found. Okay, so that starts out as true, so this part's going to be true when the program starts running, but it may become false later on, we don't know. And the second part is digits checked is less than 5. So what we've got here is a counter. So we can see that digits checked starts at 0. So the idea is that this is going to count how many digits we've already looked at. We know before we start that there's going to be no more than 5 digits. In fact, there's going to be exactly 5 digits because we set up here get a target 5-digit number. So we know that there's going to be 5 digits, so we can say, so we can have a clause here or an expression here saying digits checked less than 5. And the idea is that this is going to start at 0, and it's going to increase every time we check a digit. So it's after increasing by 1, it's going to be 1, then it's going to be 2, then it's going to be 3, then it's going to be 4, and then it's going to be 5. When it reaches 5, this expression here becomes false, right? So if it's while digits checked is less than 5, it's true. Once digits checked becomes 5, this becomes false. And because we've got an AND here, the whole thing is only true when both parts are true. So this whole thing becomes false if either digits checked equals 5 or not found becomes false. And that's how we control how long the loop runs for. Once one of these things become false, the whole loop ends and we move on. Make sure you understand how that works. If you're not sure, you can ask on Moodle in the discussion forum. Let's move on. The loop body. So the first piece of pseudocode in the loop body is if least significant digit is 3, set not found to false. So we translate that into an if statement. So here we've got an if statement inside the loop body. So if target is our number that we read in. If target modulo 10 equals 3, then set not found to false. Okay, so what that's saying is do a integer division and take the remainder. That's what the modulo operator is. And again, go back to the previous video where I just revised the idea of integer division in the modulo operator. So take our large 5-digit number, modulo it by 10, and that results in the last digit. So if target is something large like 54,327, then target modulo 10 will be 7. So we're basically taking off the least significant digit. So if that equals 3, then set not found to false. Okay, in the example I just did, target %10 is 7. So this expression will be false, so we won't end up setting not found to be false. It'll stay as true. Then our pseudocode says divide number by 10, and we translate that into the statement here in C#. And of course, this is going to be an integer division. Okay, so we don't have a decimal place here, so it's not a double. We know that target's an integer because we set it up as an integer to start with. So this expression here is going to do an integer division. So we're basically going to drop off the least significant digit and then assign the result to target. So target's going to go from 5 digits to 4 digits. On the next iteration, it'll go from 4 to 3, and so on. As long as we haven't found the 3, it'll get down to eventually no digits. And here's an update to digits checked. So remember that we want to count how many digits we've checked so far. They start at 0. And on each iteration of the loop, we increase the counter by 1. So here's that increase by 1. Last piece of pseudocode is what happens after the loop's finished. So there's two situations when the loop's finished. Either we didn't find the digit 3 inside our 5-digit number, or we did. And so we have an if statement there that just displays one of those, one message or the other. Okay. Now I've just set up a few slides here to explain in a bit more detail what's going on with this loop. In this example, we've got target equal to 45310 and not found is set to true and digits checked to 0. So let's we've assumed that we've done this part of the code, and these are what our variables hold. Now let's dive into what happens when the loop runs. So the first pass of the loop is here. It's this bit of code here, and this corresponds. There's a bit of exclamation here, so we can see that what's happening is we're calculating target %10, and for this example, if we divided this number here by 10, we'd get 0 if we're doing the modulo. So target %10 or target modulo 10 equals 0, so we don't execute this part. Okay, so not found stays true. Then we do this bit here, we do the division by 10, target gets assigned to 4530, it's basically dropping off this last digit here. So that gets removed by the integer division by 10. Then we do the increment of digits, so digits checked becomes 1. So that's the effect. So these variables change in this way. So target becomes 4531 and digits checked becomes 1. You need to make sure you understand how that happens and why it happens, because it's very important. I mean, these are key ideas for programming, and you'll be doing this kind of thing all the time as you write your own programs. If you're not sure, you could actually implement a program that does this yourself and run it, and then make sure that it gives the correct output. Let's do the second pass of the loop. So what we can see here is both both conditions were true. Not found is still true, digits checked is 1. That part's still true, so the overall expression here is still true. So we do the second pass of the loop, and this is an outline of what happens here. We do the modulo 10 again, and this time on 4531, which will give us 1. And then we update target by dropping off the last digit with that division of 10. Okay, so target will be updated to 4531. Digits checked gets incremented to 2. Okay, so the 3 variables now look like that. Third pass through the loop, we now are in a slightly different situation because we've got to the point where the least significant digit of target is now 3. So we run through this loop. We do target %10. Does it equal 3? Well, in this case, it does equal 3. Okay, so the modulo, when you divide 453 by 10, the remainder is 3. So that's what this modulo operator is telling us. Is the remainder equal to 3? That's what that expression says. So yes, this time it is. So this becomes true. So we set not found to false. We can't stop there. We've got to complete the body of the loop. So we now do target gets target divided by 10. So target there becomes 45, and we increment digits checked. Okay, so these are the updates. Now, note that we've changed not found. In the first 2 iterations of the loop, not found was true. This time, not found is false. So that's going to have an influence on our loop, because if you recall, the loop consists of 2 parts. Both parts have to be true. The first part is still going to be, the second part is still going to be true because digits checked is only 3 at the moment, and 3 is less than 5. So this bit will be true, but we've set not found to false. So not found is our flag that we use, and we set that to false whenever we find the digit 3. So not found got set to false, and therefore this whole thing is going to be false because of the and therefore the loop is going to exit. Okay, so false and true results in the value false, and the loop doesn't execute for the 4th time. It only executes for 1 time, or for 3 times, sorry. And so we get down and we then do this final if statement down here. Since not found is false, it'll be if false, and so we'll do the else part, so we say that we found digit 3. Okay, so one thing you could work through here is what happens if target does not have a 3. So it might be the number 22,999, so there's no 3 there. So what would happen? In this case, not found will be true forever. So we'll never execute this statement here, because this will be false forever. In this case, the loop will keep going 5 times, and it will only stop when digits checked becomes 5. Okay, so it's going to do 5 iterations of the loop. It's going to do the iteration where digits checked is 0, the iteration where digits checked is 1, when it's 2, when it's 3, and when it's 4. When it's 5, then that expression becomes false, so the while loop doesn't happen again. So the maximum number of times this loop can execute is 5. Okay, make sure you understand how that example works, because it's quite important. It's a complicated example, but there's a lot of interesting ideas and concepts in it that are useful for you to know about, and the things that you can use in your own programs.